Hello, and welcome to Geek Orthodox. I'm Father Justin, geek from my youth. This is the final, at least formally, the final episode of the World of Code arc of the Geek Orthodox podcast. It's been almost 2 years now, and I knew that this was going to be a big topic. That's why I plan to do an entire arc of my Geek Orthodox podcast on this. I did not expect this subject to take over for 2 years. Nor did I expect the subject that we were covering in this podcast to change so dramatically over the course of that 2 years. We've gone from what I have described as the world of code in which we live and move and breathe and have our being, and we've gone from looking at the very beginnings of that, at least the beginnings of my engagement with that with BASIC, all the way through now to AI. And as we've done so, AI has radically changed the whole landscape of the world of code. So we've gotten somewhat technical, and that was deliberate because I wanted to look at the technical underpinnings of this world of code that we've created and which has become the foundation for most of the information exchange and economic engine of our modern society, and is being rolled out in all sorts of other aspects as well, even down to the humble light switch. But as we've done this, AI has been getting better and better and better. So near the beginning of this, actually even before I think I began the World of Code arc of the podcast, I was working on a personal project of my own where I was taking my very favorite computer game, Stellar Empires, that I played as a kid on my Curious 80 color computer, and that really inspired me to get into the world of code. I was taking that game and trying to port it from one old version of BASIC, Curious 80 color computer BASIC, to a modern new version of BASIC, so I could build myself a little handheld version of Stellar Empires. And I thought that I would use AI to do that. Didn't work. This, of course, was almost 2 years ago now. But the AI just was not up to the task of porting from one obscure BASIC language to another, probably almost as obscure BASIC language. It just couldn't manage it. Fast forward now to almost 2 years later, and I have now managed to get the AI to port the original Stellar Empires from TRS-80 Color Computer BASIC to a multiplayer online web version of it, which is pretty much as faithful as I can possibly make it. So in this case, or as the AI can possibly make it, I'm going to send a fleet using command number 6 from Capella to Mizar. I happen to know that it's called Mizar because I've played this game so many times. And I'm going to just send 5 ships, and then on turn 2, all of a sudden, now Mizar is a part of my empire. So it's an awesome little game. If you want to play it, I've got it up on my personal website, and I can send a link in the description of the video. The point is, AI has radically changed how we code, how code is generated. It hasn't replaced code, and that's actually one of the most important points I want to make here. AI is, it's been said that English is the new programming language. Fair enough. That is kind of sort of true, but it isn't actually. Because when we prompt AI to create an app for us, which we can do now with great ease, what the AI does is it generates an application which is coded in one of the many intermediate computer languages that we have created to make it possible for us to interact with computers. which make it possible for us to generate the code that controls computers, that makes. So all of this stuff that we have been talking about is now being backgrounded by AI, but it's still around. It's still what the our world of code operates on. And that I want to that's a point I want to drive home, because this is, in my opinion, a continuation of the overall trend that we've seen in computer science as we've extended the science of computing to the world in which we live. We started with some pretty basic stuff. Computers were made of vacuum tubes, and that was basically light bulbs, large banks of light bulbs that turned off and on again. And so we then moved from that to integrating it down to transistors, and then integrating that into silicon chips, which are massively integrated circuits. And as we worked on that physical technology of miniaturizing computers, that gave us more and more power to work with for these kind of infinitely extensible machines. As we got more power, the programs that we needed to make to run and take advantage of that power got more and more complicated. And as that happened, we had to abstract away from the basic hardware to a layer that we call high-level programming languages. C, for example, or BASIC is the one that we've been looking at here in the World of Code podcast. And these high-level languages were designed to look something like English. So if you go back and look at some of the previous episodes of my podcast, when we were actually building a basic application, you can see that we use if-then statements, and they look a little bit like a sentence with some equations thrown in. And so it's making computers comprehensible to us, so that we abstract away, or more easily comprehensible to us, so that we abstract away some of the complexity of the computer technology behind something that looks a little bit like the English language that we know and mostly love. That's the high-level computer programming languages that displaced machine code and assembly language that was still in use if you wanted to create a really fast program in my day. As things continued on, and we got more power and were able to make more complicated programs that did more, we now had more and more layers of complexity being added to it. And so then we get various software tools like integrated development environments, IDEs, or software development kits, SDKs, or entire physics engines like Unity or Unreal Engine, where much of that coding is no longer done by the individual coder, the individual programmer, but is done by other programmers in the background that then allows the new programmer to build on top of all those layers of complexity. So what we're doing here, with the pattern that we're seeing, is we're taking advantage of the increasing power of the computer technology, which leads to increasing complexity, which leads to the need to abstract away some of those layers of complexity behind things that we build on top of, first of all, machine code, and then higher level programming languages, and then software development kits. And now what we are seeing is the continuation of this, abstracting away of that complexity with AI. So we talked a bit about AI in the last episode. It's kind of a massive prediction engine, at least AI as it's currently in the news, and as it's currently revolutionizing our society. These large language models, which are basically, I would say, mining language for patterns of meaning and functionality, some of which we didn't even anticipate. So, for example, we didn't necessarily set out to create a better translation machine. But because of all the many language data sets that the AIs were trained on, it soon became apparent that AI is actually pretty good at translation, even better than some of the translation technology that we used to rely on with, say, Google Translate. Um, such that when I went to Japan recently, I actually and had to get in touch with my Japanese friend who's in Osaka, who speaks Osaka-ben, the local Osaka language variant of Japanese. I could actually ask the AI to translate not only into Japanese, but translate right into Osaka-ben, the Osaka dialect of Japanese. So AI then has allowed us now to move from the sort of basic, hey, look, it can almost do a computer program that works, to now, at this point, programming consists not so much of actual coding. Well, there's still lots of people who are doing actual coding, and probably will be for some time to come, but more prompting the AI to create code for us that does what we want. And when it doesn't work, when there's an error or something, all we need to do is take that error and feed it back into the AI and say, hey, this isn't working, please fix it. And it will fix it for us. And it'll do really cool things like recreate my favorite basic computer game as a multiplayer online game, which if anybody wants to play with me, I'm more than happy to set up an online game with them. So, since this is the last episode of The World of Code, last formal episode, one of the things I want to look at is, what does this all mean? Is AI going to absolutely destroy the world and blow up the world of code? I don't know. I mean, it's early days. It's a new technology, has some of the potential for that. Just watch the Terminator movies or The Matrix. AI is kind of dumb. It'll do exactly what we tell it to, kind of like computers have always done from the very beginning. And if we tell it to do something in a way that isn't clear, like, hey, let's solve this environmental problem, and it thinks, oh, well, the basic environmental problem based on the data that I've been analyzing is human beings, so we should just get rid of human beings, that could be bad. Or it could instead move in the direction of, say, atomic technology. We discovered, for better or for worse, how to split the atom. And that has led to massive atomic weapons buildup, which is still there in the background, such that we could probably destroy most of civilization many times over if somebody does something wrong and pushes the wrong button. But at the same time, we have somehow managed to avoid doing that for the last generation or two that we've had this technology. So it's also not impossible that with this new technology of AI, we will actually manage to use it responsibly and wisely, or at least maybe more accurately, semi-responsibly, somewhat wisely. It's not impossible. We've done it before with every technology that we've invented so far. Is this one going to be different? Don't know. We'll have to find out. My hope, as we have looked at the world of code, as we have looked at the development of the rise of AI, as we've looked at how this technology, computing technology, which is now foundational to our modern civilization, has developed and the strengths and weaknesses of it have become, I hope, somewhat apparent. My hope is that we can take this deeper understanding of the world of code that still is the world in which we live and move and breathe and have our being, and think about how, not merely how to use it for good or for evil. We should definitely be thinking about that. But my hope is that we can also start thinking about, how does it affect us? How is it affecting us? How is it affecting how we communicate with one another? How does texting someone on a phone differ from actually talking to them face to face, or even just using the older technology of picking up the phone and talking to them? Every single one of these choices that we make has an effect that we don't always think about, because it's just part of the world in which we live and move and breathe and have our being. It's like, the fish that doesn't think about the water that it swims in. That's us. But we're a little more intelligent than the fish. So we do think about the water that we swim in, or we can. And that's my hope and my desire for what I've attempted to set out to achieve here in the World of Code podcast. And speaking of that, speaking of the way in which technology shifts and alters and influences our experience of the world, that's been true of the podcast as well. When I started out, this was an audio podcast. Now I've moved to it being more of a video podcast. But at the same time, I've been posting more and more on Substack in writing. Very different technologies: audio, video, writing, each of which has its strengths and its weaknesses. With audio, I wasn't able to show any of the code that I was working on. It was a bit of an impractical to narrate the code. Video allowed me to do that. Text allows me to do that as well. Text is less engaging, perhaps, or for those of us who like reading, maybe more engaging. So each of these technologies that we embrace, whether they be the ancient one of writing, or the even more ancient one of speaking, or the modern one of delivering video, has its strengths, its weaknesses, and affects how this communication that we engage in affects us. So, this is the end of the World of Code arc of the Geek Orthodox podcast. Not the end of the World of Code, not the end of the World of Code episodes, but the end of this arc. What is the conclusion of the matter? As I wrote in my Substack, my starting goal in the World of Code podcast was to help anyone who was interested understand the nature and the ubiquity of the world of code. My intent then was to draw people in and to give those who are interested the tools to understand what this world of code is and how it affects us. That ends up being the necessary conclusion of the matter in the age of AI, even more so. Because the temptation in the age of AI is to give up our agency to the computers, a la all the fat people in WALL-E who are gliding around on their hover chairs. But the AI actually needs us as the human in the loop, as the ones who are engaged, who understand, who are given the task of being the masters, being the stewards of creation. It needs us to both understand this world that we live in and that we've created for ourselves, and to guide the development of and the usage of this world, the direction of that this world is taking us in, so that as we live and move and breathe and have our being in this world of code, as we continue to direct it, it takes us in directions which do not disengage us from reality, which do not disengage us from one another, but which allow us to focus on the reality in which we live, focus on one another in ways that are loving and kind and human, and that embody the teachings of the most important person who has ever lived, who is the creator not only of us who created the world of code, but of the world itself. Because it's ultimately in him that we live and move, breathe, and have our being.